Welcome to Beyond Tech, where innovation meets insight. I'm your host, Jackie Slatt, and today I'm joined by a special guest co-host, Dave O'Brien. Dave is a business development manager here at eTech Group. And because he's out in the field every day, talking with clients, touring facilities, and seeing both the challenges and the breakthroughs firsthand, he brings an invaluable real-world perspective to this conversation. We're also joined by two of our subject matter experts from eTech Group's Lab Automation and Industrial Robotics team, Sura Hadi, Director of Laboratory Automation and Industrial Robotics, along with Niket, an automation and controls engineer who works closely with clients on the integration of automation, data systems, and enterprise platforms. And that's exactly what we want to explore today. Across pharma and biotech, we're seeing labs invest heavily in the automation of robots, instruments, and work cells. But many organizations still struggle to move beyond isolated tasks or proof of concept projects. The real question isn't whether labs can automate individual workflows, it's whether they can connect those systems and scale them across sites and turn lab data into enterprise level insight. Today's conversation is going to dig into that gap. We'll talk about the difference between task level automation and true digital transformation, why data architecture and system connectivity matter just as much as the robots themselves, and what it really takes to bridge OT and IT in regulated lab environments. We'll also look at common pitfalls, the role of upfront design and feed studies, and how organizations can set themselves up for long-term success as analytics, AI, and cloud platforms become more deeply embedded into the lab. So today we're diving into what's working, what's emerging, and what still needs solving in lab automation and digital transformation across pharma and biotech. So let's get into it, and I will hand it off to Dave.
Thanks, Jackie. Yeah, great to be back here. I did this not that long ago. It was a lot of fun, so happy to be back.
We're happy to have you back.
So just I want to just start high level, right? Let's talk about the landscape of things. To begin, Sura, what would you say are the biggest barriers keeping automation projects from scaling beyond individual tasks or islands of innovation, right? I feel like that's a common thread right now. Why don't we start there?
Yeah, the islands of innovation comes up quite a lot. I think for me, what I've seen, the number one barrier is that automation is treated as a one-time capital purchase. We're just going to come in, we're going to buy the system, we're going to go. The thing that falls short when you're thinking like that is strategy. What is your long-term plan? Do you have any, need in the future? Can you think of different ways to make the system modular to use it for beyond this one workflow that you've envisioned? So you see a lot of labs buying a liquid handler, a plate reader, an arm, and they call it automation, but there's no connective tissue. So those are some of the barriers that I see, is that when you think that way without a strategy, data tends to stay siloed. It doesn't move. It generates data and it lives in that instrument. And that's not really conducive for what you want to do with the data later, how you want to connect different workflows in the future.
Makes total sense. Something that is coming to mind here, which everybody talks about, is digital transformation, right? However you want to spin it. There's positions around digital transformation right now. Every company I feel has someone or even a group that's focusing on this, whether it's paper to glass or whatnot. When a client comes to you saying they want to digitally transform their lab, what does that mean in practice? What does that mean to you? How does automation fit into that?
It's interesting because, it's kind of like how a lot of things get put under AI that people were already doing. It's the same thing with digital transformation. There are a lot of things that labs and teams have already been doing that now get nested under digital transformation. So it gets thrown around a lot. And I think what it means to the stakeholders, to the people, that actually have to put together the budget and fund it is, hey, you bought those robots. Now we want to see the ROI, the return on investment, right? And so it's not so much the transformation, it's the automation. And the real difference is making sure that they understand and get the value out of it. Because automation makes a task faster and it removes a manual step. So that's physical. You can see it. And transformation, I think, is what happens when that work and the data it generates actually changes how decisions get made in the lab and at the enterprise level, right? So a scientist in Boston seeing what a robot is doing in Vacaville last night, that's important. And batch records that it generate automatically is important.
Oh, for sure. Makes total sense. You hear that a lot. It's a common thread for sure. Related to that, so talk about data architecture for a moment. Why are data architecture and system connectivity now just as important as robotics? Even the instruments themselves for them.
Yeah, I guess me and Niket are coming from the space where we know robots, we know how they connect, we know how to run them. So for us, the robot's the easy part. right? It's pretty straightforward. I think the hard part is what happens to the data after the robot runs. And in the past, pharma labs could afford for data to sit in silos, and I don't even believe that they could have afforded it back then. But the regulatory timelines were pretty long, the decisions made were pretty slow. Today you see this like speed to insight. This is a competition between these companies, and it's a differentiator. So if your PCR robot generates results and it takes 3 days to get back to the scientist's dashboard, then you can consider the automation having not solved the problem at all, because you're not getting that feedback. And when you put the right data architecture in place, this determines whether your automation investment has ROI or is just a cool tool, cool hardware that you spent like $500,000 on, right? When we work with life sciences clients, the asks are increasingly about connectivity, not more robots.
Exactly. Yeah, the finance folks don't want to hear that. Assets not being used to their full potential for sure. So
Yeah. Would you add anything to that, Niket?
Like Sura mentioned, right, the main thing beyond just the instrument purchase is the data that comes off of the instrument. And there's just large sums of data that we don't necessarily want the scientists spending their time, parsing out or compiling. So a lot of the LIMS efforts that we have, takes that time, gives it back to the scientists and kind of standardizes these data transformation processes across different labs to really, create like a uniform structure by which this data is being processed, stored, and then later you can, go back to it. So the data aspect is huge in addition to the purchase of the equipment as well, in terms of how it's going to be managed.
And that's a good point. Imagine like you buy a really cool, it's a great instrument, right? And that does all the work on its own. It's sort of like magic, right? It does everything. It runs a lot of data points. And so you get these 200 to 300 results that then somebody has to manually type or even copy into an existing LIMS system after each run. So as you can imagine, that 300 result just keeps stacking up. So if you have tens of hundreds of these instruments across your labs, tens of other types of instruments, now you're running a high throughput lab, but you're constrained by the manual data that you have to move over. If you can tie this instrumentation and have it just simply feed the results directly into LIMS, the amount of time, labor, and cost saved, beyond the fact that you're getting to that decision faster, you can imagine that's a brand new world in this competitive space.
no, that makes total sense. I think that's a nice, nice high level description there of, where things are at. So thanks for that color. To get more granular, so let's start to break down, let's talk about connecting the bench to the enterprise, right? So to start with that, what does it look like when a lab evolves from fragmented point solutions to a connected, even enterprise-wide automation ecosystem?
And this is where it's really important to have a partner like eTech in the space, because we can kind of take a step back and really highlight that broad view of where you are now and where you want to go. We see a lot of clients, they have labs and all the labs are sort of acting on their own. So that's where you have your islands of automation. The instruments are doing their job. The data is manually transcribed or stuck in flat files that then get moved. And that's what we call, right, stage one. This is something that's in place. It's working. Great. Stage two is where we like to see these integrated workflows. So this is where we talk about instruments talking to a LIMS. The results are flowing automatically. Some robotics in the loop. No one is really taking a file, moving it by hand. And that takes you to that next level of connectivity. When you want to get to stage three, the connected enterprise, we're talking now about lab data that feeds into ERP, QMS, supply chain, real-time dashboards. This is super important, right? Real-time analytics, predictive analytics on run outcomes. This is really important. And so this journey isn't usually linear, right? Most clients are stuck between stage 1 and 2, and they need a bridge. And usually what triggers that shift is working with companies like ours. Generally, they come to us when they have a compliance event or a major expansion or an initiative that forces the issue. And we want to make sure that we're connected and having that conversation from the outset so that we can help them build that journey, so that there isn't a lot of this waiting time where you have to get the infrastructure in place. One of our large pharma clients had 6 different LIMS instances across sites with no shared, what we call taxonomy. And unifying that was the foundation of everything else that we built with them.
Yeah, you do hear a lot about the technical debt that a lot of these labs have. I think that's a pretty common thread people are experiencing right now, especially as companies acquire other companies too. They like, they're acquiring this pile of platforms, which is
And
interesting.
that's an important distinction as companies are acquiring other companies, and now they have to sort of shoehorn into different modalities and ways of working and different enterprise solutions that are in place. And for me, because I am taking a step back and our team is looking at it agnostically, we can help drive some of those conversations to piece these together in a really important way so that you can get up to speed and running.
Right. Makes sense. So let's talk about that. So we're kind of getting into the digital stack now, right? So there's LIMS, there's LIS, there's MES, SCADA, cloud analytics, take your pick. How do all these things fit into that larger?
Yeah, that's a good question. I think, and you see this because these are the stacks of different companies and they're not competing systems. They should work together. So when you're looking at SCADA, DCS, like the OT layer, that's real-time instrument control, sensor data, PLCs, and Niket can speak to that a little bit more, right? And then you have MES, so that's the manufacturing execution that tracks lot, batch, process in real time. And you have LIMS, the laboratory information management systems, where sample data, results, and workflows live. So this is really important. And the problem that we see in most labs, they have some or all of these, but they don't talk to each other. And our role is often the system integrator that builds the bridges between these layers. And we're not trying to replace them. We don't come in and say, you need to buy and change everything. We try to think about what do you have and how do we connect them? And the hierarchy here matters, right? Certain layers to become stable before you build a reliable integration. So, you need an OT layer that's stable, and then you could build a reliable LIMS integration. And when people skip steps, that's when we see this execution fail or start at the beginning or have a harder time than it needs to. And all of these things don't have to compete, right? They can work together to produce the best outcome for you.
Makes sense.
Anything
Niket,
to add, Niket?
yeah, I was going to say, Niket, I wanted to give you a chance to comment here. Do
He's
you have any
shaking his head.
thoughts?
Yeah, definitely. When you have a lab or a manufacturing site, you have different projects or programs with different systems. Systems might be on different software versions, running, non-standardized protocols. And like Sura said, there's levels of automation, right? Either some processes are completely manual or semi-automated or fully automated. And it's basically our job as automation engineers to promote and get that stakeholder buy-in that this is the path we want to proceed. A lot of the times that is the biggest challenge is scientists may be apprehensive, right? But kind of showing them, like Sura mentioned, the ROI and the time that it gives back to them to be able to focus on the data or to be focused on innovation rather than doing these manual and repetitive tasks, I think is the true value add. So it's also, in addition to the engineering, it's also this back and forth that we're constantly doing to reassure that this scientists are truly going to get value for this equipment/process they're trying to automate.
And you touched on an important point, right? Is that it's the stakeholder buy-in, right? We might get looped into the pain points by the scientist or whoever is, putting in that lead request or talking to us at conferences. But the stakeholders are beyond that one scientist looking at how to automate their workflow. You need to make sure you have the IT solution involved. You have to talk to those stakeholders. You have to make sure you're talking to the other scientists and other labs that downstream of what the workflow this scientist is doing. And I think the most important thing that we do is really bring that conversation and pivot it around who's involved, where does this start, where does it go, and how many other people do we have to have buy-in from to make it a really robust solution.
So, Sarah, you said two letters that bring up another question, IT. You're talking about OT, IT convergence, right? That's happening everywhere. That's a hot topic in a lot of different companies. A lot of our clients are obviously experienced in that. How do you help clients understand the value of OT, IT convergence before they start buying equipment, even software for that matter?
That's a good question. And I think I'm going to, do a little shout out to our IT/OT vertical here at
Yes.
eTech. The laboratory automation and industrial robotics group, of which me and Niket are speaking from, we are very specialized on the laboratory instrumentation and how that connectivity works. So the IT/OT pain points for us start with the pain points, not the technology, right? So how many hours a week does the team spend manually moving data from instrument exports to LIMS? That number shocks people, but that's our limited realm. The bigger questions around IT/OT, we bring in the IT/OT vertical from eTech. But the lab OT/IT convergence can sound abstract until you map it, right? And once you start mapping it, reduced error rates, faster batch release, fewer observations. Those are important to move from the current state to the future state. And this mapping exercise, we don't see a lot of people engage in, sometimes because it is tedious, sometimes because you don't actually know what you're mapping to and from. But this literally can show our clients where data is stranded. And when you find that, you can liberate it from that location. And for our regulatory clients, we frame it around data integrity, audit readiness, and that language really lands with their quality teams and with their leadership, because those are the things that they may get dinged on if they don't rectify.
CFR 21 Part 11 come into play at all?
To a certain extent, you have to make sure you're meeting those standards and regulations, and your systems that are in place can meet that standard. I think the ROI framework here that we want to move for is the time savings and error reduction, which allows the speed to market and the risk reduction eventually. And when we do talk to clients that are in this space that are facing these kind of issues that may be looming, we try to always think about, can we do an assessment? Can we do a front end engineering design for you, right? And when we do that, we understand, what do you know, what don't you know, and what do we need to know to accomplish this goal? And because it's a lower barrier for us to engage, it is really interesting to most clients, because then they can engage with us. We can kind of show how we can deal with these problems and map out the solutions, and then buy-in happens, and then we can actually put the project in place.
Just to touch on kind of the compliance part, I know Dave mentioned the 21 CFR Part 11, right? Highly critical for GMP organizations, especially for how they're storing their data, anything user permissions related. From the layer perspective, though, because it's for the most part, the target would be in labs, whether they're process development labs, early stage labs, and whatnot. We are following a lot of the same data security principles. But again, our approach to data is more so what are the sources of data that people are dealing with that can be automated, like no manual work would be needed. So we're kind of taking that approach to data, is looking at all the data coming off of the instrument, data feeding into other processes, and at the same time ensuring that we are maintaining the security of that data per the organization's requirements.
Very cool.
I want to kind of shift over, because I think you hit on the importance of data, and I feel like you guys probably both have an example of where the automation and data systems accelerated the speed to insight or the reduced cycle time. Can you both share an example?
Sure. So I think for us, it's kind of like a show and tell. We can always show how having the right connectivity, the right architecture can liberate data and make it more important and, tie into the overall scheme. I think for us, the large clinical diagnostic clients where sample processing was automated at the bench level, but results were being manually keyed into two different systems, right? So you can just already imagine how that could go wrong. We integrated the robotic work cell directly into their LIS, eliminated manual transcription, added automatic QC flags, and reduced reporting cycle time significantly just by doing that. So this is a case where the automation was already there, and the transformation happened with this integration layer. So that's really important, because we were able to flex what they already had on hand and make it work cohesively better so that the data was meaningful.
Yeah, sir, that actually reminds me two things, right? One is what we just talked about is taking data and processing that, right? A lot of people don't even know you can take a PDF, text, or other types of files and parse that data.
Right.
But a thing that I thought about just now, Sarah, was one of the projects we worked on is automation to create more and more sets of data. For example, one of the normalizations we did using the Lynx head with variable pipetting volumes that could be programmed to really study the different media compositions, right, for growth. So that created more data sets for us to be able to analyze, for the scientists to be able to analyze. That's another example of automation coming in, not to process data, but to create more data sets to allow for better decision making down the line.
Yeah, good point.
I want to flip this a little bit. Are there any has there ever been a situation where a lab invested heavily in automation but failed to see an ROI because perhaps the architecture or the connectivity wasn't in place, wasn't there to begin with.
Yeah, it's interesting that you asked that because it's definitely more common than anyone in the industry likes to admit, right? And it's a classic failure pattern that I see. Pharma companies will buy like a $2 million robot system and it runs beautifully for 18 months doing the thing that they bought it to do. And then after they're done with that thing, it sits idle, right? Either because they didn't envision how it could modularly be moved or shifted to accommodate other workflows, or the programming and scripting was tied to that OEM and they don't have support to create more programs, but also because the limbs it was supposed to feed into got upgraded and no one maintained the integration. No one knew that system, no one knew the cell, right? And so that integration failed. So that broke the data acquisition. And now we're back in this space where we can't generate the amount of data that this actually promised, the system promised, because we have to manually deal with it and upload it into LIMS. So what do we do, right? And do we have the right personnel with the right expertise to bridge that gap? So that's just one pattern that we've seen that kind of ties into the work cell and the data, the LIMS system. Another pattern is just the automation built around that one scientific team's workflow, and it can't be replicated because there's no standardized data model. And I think that's really important as well. These proof of concept automation that's perpetually like in pilot, right?
Niket, did you want to add anything to that?
Process mapping. Yeah, I'm going to restart that one. I think, like you said, process mapping and really defining user requirements early on before purchase is highly critical, probably the most important thing, because not only after, you're using the system for its intended workflow or process, after, are there other potential uses for the system? Is it modular enough to be able to use in other parts of the business, right? So these considerations have to be made, and getting down to like the component level too, like, are we really getting the best system? Is it able to do each of the individual smaller processes of the larger workflow? Because there's so many vendors and so many options. I think like identifying that system is highly critical, because the last thing you'd want is equipment sitting there unused.
That's the thing that hurts us the most when Niket and I walk into a lab and we see this awesome system that's in a corner. Now people have put cardboard boxes and tip boxes on top of it. No one's using it. And we're just like, oh my God, you could totally use this to do what you're doing right now, right? It just hurts.
Yeah. I've been to a few sites with a couple idle liquid handlers and
who shall not be named.
Who shall not be named. But they've just been sitting there and no really plan in sight. But
and as we're taking the tour, we're like, we can help you program that, right?
Yeah.
I know. That's a key. I think that's a key piece of like the philosophy of Layer, right? Is like, let's maximize the assets that you have. Let's try to use what's currently on the floor. What can we tap into?
Yeah, and these systems were made to last. Like, yes, the technology does get better. Yes, now we have, like the link systems with modules that have chips in them that can accurately read the pressure. But even those old systems that came out years and years and years ago, you could still get ROI just by automating what you're doing now on them, right? And we can help you with that, right? You don't have to be the PhD scientist, the lab automation engineer, and the software engineer. You could focus on the science and we can get that dinosaur to play, right?
Yeah. Exactly.
The importance of having like a feed study or a front end engineering and design to really plan out and think through what you're purchasing, what you can reuse, and all the different teams that I think need to be involved in the discussions. Can you speak to that a little bit?
Yeah, and that's really important. The feed is something that I think of as a pre-project investment. And this is super critical to getting the design right before you commit to build. Like Niket said, there's a lot of integrators in the space. There's a lot of, OEM vendors that are trying to sell you the solution that works for you. To make a really intelligent, decision, you have to assess all of them, but really who has the time, right? And sometimes you don't even know what it is you don't know. And so offering this front-end engineering design is really important because it allows you to put in a small investment, and this allows you to get the design right and pick the right vendor for you that can meet that. especially critical for automation and digital transformation projects, because this allows you to, I think, de-risk the architecture before you spend real money on hardware, software licenses. We see these purchases of these huge robots that don't end up doing what you think they're going to do. And what we do in these feeds is, current state assessments, we do gap analysis, integration mapping. We even help with vendor evaluation because we play so nice in the space and we're vendor agnostic. We can actually help, de-risk and look at these different vendors you're considering, create like a risk register and even a schedule and a budget. We've even had some clients that have gotten a full data architecture out of the feed study so that they can put in place the systems that they need. Right? The Lair team uses feed engagements to build these technical foundations all the time.
Yeah, fully agree. It's basically on an engagement basis, right? It's whatever the customer needs, we're happy to provide. We have our team of experts that have done this for years, right? We know the systems, we know the LIMS infrastructure, we know the best way to implement your process. We just want your input along the way so that we can deliver the best product to the end user. So fully agree, come in with an approach of, all right, what do you need? What's the best way to get there? And completely flexible in our approach, right, Sura? I think we're pretty...
And if you don't know what you need,
well,
we'll help you
we'll
get
help
there.
you. I
I
mean,
really
if you're
think
not sure.
I really think they're underused in life science automation. Everyone wants to get to like the end goal. And that's why we see this disconnect before, like, this isn't what I ordered, or, we talked about this and now you're giving me this. It's really important. I'd argue feed studies are highly underused. And I think, we see that in other spaces being used much more robustly, but in life science, not so much. Don't you think, Dave? You've sold some feed studies
I think
elsewhere.
I was thinking about this as you guys were giving your answers here. To me, like the stakeholder alignment thing is big, right? Because especially in a lab, there's so many different types of people, and like everybody has their wants and desires, right? And some things are more important to others. And they're not always talking either. I mean, you think about like IT, OT. Sometimes IT is just off in their own world, perhaps. So I think to me, like the feed study, like connecting everybody and making sure all the stakeholders are on the same page and everyone's voice is heard, I think that's really important and critical for a good project and this kind of thing. Again, I think it goes across the board with any automation project, but especially in the lab environment where it's like, it's almost this unique thing. It's kind of hard to explain, but to me, the stakeholder alignment is one of the most important things. And I think this really helps align everybody to make sure everybody's on the same page and has those needs, wants, and desires answered before they spend millions of dollars on these pieces of equipment, to your point.
And it's a lower chunk of money, right? So
yes,
I think Dave and I have been in labs where someone, one lab orders the centrifuge, the other lab orders the router so that they can make the budget work. This is very low entry point.
Typically, we find your overall cost of ownership from the project is less because you do the feed study. You can like really narrow down what's important. It actually does help from a budgetary standpoint to do that up front. So it does please the finance folks too, believe it or not.
Got to make procurement happy.
Yes, yes, you do. So no, that's cool. Something else I was thinking of as you guys are talking, like talk about like cloud strategy, data governance, and even like machine intelligence initiatives. How should organizations think about that as they're, maybe not necessarily in the feed stage, but like when they're designing their automation roadmap? How do those things come into play?
Yeah, and that's a big thing that they're tackling, right? So I think it always gets a little overwhelming because, where do you start and how do we make sure we catch everything? And, we always recommend start with the question, what decisions are you trying to make faster or better? And then you work backwards from there to the data infrastructure. And that makes it a little bit easier to really come to a strategy, especially for, the cloud strategy. Sometimes IT will try to drive this in isolation. So without, working with the lab or talking to the lab, just because that's kind of where they live naturally. The lab has to be at the table because the instrument data formats and connectivity are often the constraint. And we see this in a lot of our projects. I mean, we're on a project right now, right? Looking at the different ways these data formats get accessed and exported. Very important to make sure that that voice is heard so that something doesn't roll out from that, from IT that doesn't really fit into what you're trying to do in the lab itself.
Niket, do you have anything on that?
Yeah, it's right. It's looking at what data is accessible. Having data stored locally is costly. So definitely looking at cloud storage solutions for, expanding data is the right approach. For expanding data needs is the right approach. And yeah, it's again, stakeholder buy-in as to what needs to be prioritized. What are the data sources that are causing the biggest pain points? What do we want to address first? And so, yeah, again, it comes back to stakeholder buy-in and really engaging with the customer on how we want to approach handling the data.
I'm with you there.
It's beyond the cloud strategy though too, right? Because you have to think about data governance, and it's the foundation to everything you do. And I think a lot of times if you don't have a shared data dictionary, clear data ownership, a layer of machine learning, it's going to be a mess. And these initiatives are maturing fast in life sciences. And we're seeing clients, for example, move towards predictive analytics on assay performance for one, or forecasting yield, even predictive maintenance. We have a client right now doing that. And I think that's all something you have to think about. For organizations that are thinking about their automation roadmap, it's really important to think, what is my maturity model, right? You have the data that's available, you move to the data that's accessible, the data that's trusted, right? Because the bad data that comes in will be the data that the machine learning works on, and you want clean data that's trusted that leads to data that's actionable. And I think most labs right now are stuck at the available data because the connectivity piece and the governance work isn't really done yet. So I think that's a model we should all strive to help our clients get in place.
For sure. And I know AI is coming into play very quickly on the machine intelligence, or specifically around predictive maintenance. I think that's a really nice use case for it, even in GMP environments in some cases. Speaking of GMP, tell me about, so we've talked about a lot of different things, but like robots specifically in regulated environments. What do clients underestimate when it comes to deploying robotic systems specifically in GXP labs?
I think we mentioned this on another podcast, right, Jackie?
Probably.
Validation.
I have lots to learn about layer.
So
I've talked to you a
validation,
couple
yes.
times.
Yeah, validation. The number of teams that budget for the robot and forget to budget for IQ, OQ, and PQ is astronomically different. I have $2 million for this system, but I haven't thought about any of the documentation I need to actually, trust it. So validation is really important. And we've seen this governance gap. The documentation burden isn't like the story that we tell ourselves. It actually shows up in inspection. It's a real thing that we should think about from the beginning. And I think that's an important aspect of this that we see teams don't think about upfront. That's really important.
Yeah. And in the GMP space as well, in addition to the validations, right, in the documentation, there's the whole change control process in itself that, that overarches the whole thing. Having your qualifications or the validations you're doing align with that change control process, and just kind of iterating through that is highly critical as well.
Yeah, that's actually put a lot of projects on the rails, because every software update, every parameter change, it's potentially a change control event. So that's not a tech problem, it's a QA workflow problem that needs to be addressed and thought of at the outset. Good point.
And I know we brought it up before, but 21 CFR Part 11 certainly comes into play here. It's a pretty significant burn. That makes sense.
And that adds a significant documentation burden that may slow down timelines, right? So everything to consider. And I think the human factor also, right? Because operators need to be trained, not just on how to run the system in the robot, but how to troubleshoot and escalate. What happens if the robot fails, trained on the templates of the documentation that you want to use. So I think there's a plan that needs to be addressed, not just how do I build the robot that I need, but all this other documentation training factor around it.
So it certainly can be done. It just requires a lot of careful planning from experts like you guys, of course.
Yeah.
Appreciate it, Dave.
Shout out to Lair.
Exactly. That's what I'm here for. So no, this is a great discussion so far. Let's talk about what's on the horizon, what's next, right? Like, what does the next generation of lab automation look like? I assume AI is part of that, of course, right? It's part of everything. I'm also thinking advanced analytics, cloud native platform. They've been around for a little while, but those are starting to mature, of course. What's coming? What do you see next on the horizon here?
Sorry, Dave, I can't speak about the future. Joking. Yeah, and I think, now we're in this space where we have automation that follows rules, and we're getting into automation that actually learns, right? And this is like the point where things hopefully are going to be, driving faster and making decisions faster. We're thinking a lot about AI-driven scheduling and optimization so that you can queue other workflows, right? So robotics that can resequence a run based on priority changes or like error flags or QC flags, or if a resource isn't available, if you run out of buffer or reagent, right? So that's really important, these real-time decisions. We also see like a lot of digital twins that are becoming mainstream. And, I've seen and given talks on digital twins and how they can help different workflows. And these are things that are simulating an entire lab workflow in software. And this is important because it's ahead of committing to physical configuration. So I think the lab of the future is aiming to just not run experiments faster, but to learn from every run and to continuously improve. And there's, labs that are AI ready, labs that aren't AI ready, and it all has to do on what the infrastructure looks like underneath it. And for life sciences specifically, I expect to see some AI native quality systems that at least can flag data integrity issues in real time rather than during an audit, right? And we can set that up now, and we can call that data out to make sure that our models work and can flag that ahead of it. And this integration layer then can become more intelligent. That's just not the future, that's in the near term, right? Things like that, where we kind of draw back from AI running everything without humans to these critical pieces where it flags errors, where it flags integrity. It's not just moving data at that point, right?
Makes sense.
And robotics governance, right? You have to make sure that you're setting up the space for this kind of work. We see a lot of companies thinking about bringing these mobile robots in labs that have humans working alongside them, moving from, clean spaces to not clean spaces. There has to be real strict guidelines around how these things get set up and how they're successful. So that's a lot of things to think about. And I think the future's there and we're moving towards it and the technology's there. We just have to make sure that the underlying data underneath it, the governance, the requirements are all set up in place for that success. Let us play with your mobile robots. I've written articles, right, from our team around an AI-ready lab, how to build the right AI-ready infrastructure. We have on our team, like Niket is certified in robotic governance, right? We have that color to bring to the conversation that can help you get set up for success as you're thinking about the future lab.
But so I think all of this conversation is kind of revolving around there are a ton of possibilities, but that's really where you need to have the conversation and figure out what is most important in your situation and your lab to be able to scale to reach where you want to go. And you don't have a robot sitting in the corner because you didn't think through all of that first.
Yeah. And companies have a lot on their plate right now, and their scientists are doing so many different things. And sometimes they have these teams ready to go, and oftentimes they don't, right? They're just kind of borrowing from the IT team or making a scientist an automation engineer or trying to pull someone to program on their off day, right? And I think that's where we come in. We want to make sure that we're a resource that can be a partner in the space, and you don't have to have everything ready and all the teams in place, and we can help until either you're spinning that up or to support whatever team that's at that level, maybe not fully mature and independent, but can be supported. And I think that's important because not everyone can have this ready to go AI team.
Yeah, absolutely.
Yeah, and just to add to that, I think, Sura, what makes our team special is we are inquisitive. We want to know the pain points of our customers to be able to accurately define what they want. So to be able to get that face time, I think for us is highly critical, right? Like you mentioned, we've been talking about the feed studies. You're just anything before, they sign the check for a larger system to get our foot in the door to really understand what they need. And so we can define the project right for them.
I always tell people you can reach out to me on LinkedIn, even if it's just to like throw ideas back and forth. You don't have to hire me. I just want to hear what you're doing because it's very interesting stuff.
Just to, as we start wrapping this up, like, say I'm a leader, I'm a director of a lab or what have you. I'm listening to this podcast today, and I want to accelerate digital transformation in my lab. What is the first step? What's my next move here?
Again, I think this is something that could feel overwhelming because there's so many things you have to think about. I always say, don't buy anything yet. Like seriously, just stop. Don't buy anything. Start with a current state assessment. Let's figure out, where your data is born. Map that, right? Map where your data is born, where it lives, where it dies. And this will really allow us and allow you to understand what is your biggest pain point. Once you identify that pain point, you just follow the data. Where are people actually moving information from? Are they doing it manually? How are they getting it? What does it affect? And that's where you're going to find your integration gap. And then once you do that, you can start getting your stakeholders in the room. And that involves IT, it involves operation. And I wouldn't do this sequentially. I would do it at the same time, right? Because the number one killer of these initiatives is this divide where IT and lab aren't talking, where they are on different pages, having different approaches. And so that really doesn't help get to where you need to get to. And from then you can set your data strategy before your technology strategy, because the vendors are always going to have a lot of opinions, right? They're going to come in, they're going to propose a solution based on the limited information that they know. So you need to know your requirement first so that you're the stakeholder in the room, you're setting that conversation. And once you do that, you can look for a systems integrator partner who understands both the lab science and the enterprise architecture. And that combination is rare and valuable. And suffice it to say, the Layer team has those people on it. So we're happy to help you, because then you can build for scale from day one, even if your first project is small. And those architecture decisions that you make are the constraints that you may live with for 10 years. So, find that information, find the right partner, and then you're good to go.
Do you have anything to add, Niket?
Finding the right partner. No, finding the right partner early on. Like Sura mentioned, our team has years and years of experience in the various parts of automating lab environments. So we'll come in, do a process map, a technical evaluation of current state, look at proposed potential projects, and really try to scope out what the best plan of action is for the customer or the end user. So I think we do excel at that. And I really love what we do and happy to be part of this team.
Yeah, one of our senior engineer, he's a senior informatics engineer. He always says culture eats strategy for breakfast. He always says, foster a culture that embraces change and progress. And when you get those advocates in every section that champion that constructive change and promote it, that's where you're going to have your biggest success.
That's a great way to look at it. I like that. I want to thank you guys both for being here today. I've enjoyed this conversation. And Dave, you once again did a great job hosting. I always like to end on a couple of fun questions that just help us get to know you guys better.
Yeah, put Niket on the spot.
Niket, I have talked to Sura a few times before. This is the first time you and I are talking. So this has been, I've enjoyed virtually meeting you because we're very spread out throughout the country and world now. What is something that people assume about your job that is just totally wrong?
Yeah, it's nice to meet you virtually as well, Jackie. And I think one thing people assume is we are there as automation engineers to just replace the work of others rather than give time back. I think they're coming in from, maybe they'll think, okay, they're just here to have a robot come in and do the work for me, rather than it be the other way around. We're giving the scientists or the end user time back to focus on things that actually matter. So I think lab automation in our space might have a negative connotation, or that speaks to a little bit of the apprehension scientists have in bringing these technologies in. But we're there at the end of the day to make their lives easier, and that's something that it is our job to convey that's what we're here for, and to give that time back to them.
What about you, Sura?
Yeah, I think that the thing I like about Niket's answer is it really highlights, some of the things that people do think about automation beyond that is that it makes things simpler. And in a way it does, but we view it as shifting the complexity, right? The manual processes can fail visibly, but the automated ones fail silently at scale and with a paper trail. So that's what we, think about. For the team, you picture someone programming robot arms, and the reality is, I'm in a room with R&D and IT directors, quality leads, and operations managers, and trying to get everyone to agree on what the data should look like before a single cable gets plugged in. And that's the most important part, not just the robots and the physical hardware. It's that data flow, stakeholder alignment, and change management that Niket mentioned earlier.
I think those are both good answers. Okay, I like this question a lot too. If you could ban one buzzword from the industry for a year, for I guess this year, what would it be? What are you sick and tired of hearing about?
It's defunded. When projects lose their budget,
That's a good one. Yeah.
They do not get funded to move forward.
I gotta say, I do feel really upset when I hear you tell me that, because you work on a proposal and you're envisioning the design and how you're going to approach it, and you're queuing up the engineers and everyone's excited, and then Dave says it's been defunded, and I'm just like, dude.
And you feel bad for the person you're working with. I mean, it's like, they ask for
Because
the
they're
money.
excited too. Yeah.
Yes, it does become like a personal thing in some ways, because they've done a lot of work internally. You've kind of helped them come up with the vision, and sometimes you even help them sell it internally to say, like, this is obviously, we talked about ROI a lot in this podcast, but you're prepping your stakeholder, your contact, to try to go out and get that money. And there's a level of excitement that they have because it's going to improve their day-to-day, right? And when they don't get that, it can be pretty sad, believe it or not. So it's not just a monetary thing. I think there's very much a personal element behind that.
The emotional thing behind it.
Yeah. I think for me, I'd like to ban the word turnkey. Every time I hear it, I'm like, oh, because nothing really in regulated life science is turnkey. The word is closed a lot of, I think from what I've seen from clients engaging, with other vendors, it seems like it's closed a lot more bad deals and started more painful projects than any other term that I've seen in industry. They're like, oh, it's turnkey. We'll just drag and drop into this lab. It'll be great. And it never works out that way. It's a misnomer for sure.
Think for myself, not possible. So I think everything's possible with a budget. And like Dave said, sometimes the funding isn't there. We believe that we can automate anything, given requirements. But a lot of the times it's just that there's no money for the projects, and it's not just a financial thing, right? It's scientists that really want this thing. They know it's going to make their day-to-day easier, but there just isn't funding at times. In combination with the funding, I think perceiving something as possible, I think is the best way we want to approach things.
I like that answer, because I think a lot of times when you're thinking about a solution, it's big. But when we talk to folks, we try to piecemeal it. If you only have the budget, this is what's possible versus the whole thing is impossible. So that's a good pivot on the viewpoint, right? Is what could we deliver today that can help you at least alleviate some of your pain points, even though the bigger way we might approach it might take a little bit more budget or time.
Yeah, I think that was a good answer as well. So I have one final question for you guys. What is one question that you think every lab should be asking, but that they aren't?
I think for me, the most important thing is, who owns this system, after a year on day 366, right? Not during implementation, not during hypercare, a year from now when the vendor's project team is gone, something breaks. If you can't answer that question, you don't have a support plan, and you need a support plan, right? We have our support services or 24/7 team. Our engineers are trained on this as well. But if you're not thinking about that, then you've spent, a year working and building workflows on this system without thinking about what happens if something fails, with the hardware, with the software, if you need to reprogram or script anything. We've talked about this before. Your system will sit idle. You won't be able to tie it to LIMS. Your data won't be able to get retrieved. So who owns the system on day 366, I would say?
Yeah. And I think for myself, the question that labs should be asking is, what are our highest priority workflows that are high volume that can potentially be automated? Because I think it starts there, is taking a kind of a bird's eye view approach at the whole organization. What are all of our processes? Where is a lot of the manual labor coming in, and where can we potentially find solutions? So I think that would be it, is looking at it from kind of bigger picture, stepping back and saying, okay, what workflows do we have that can be possibly automated, and what are the potential ways to go about it?
Well, I like those answers. I don't think I have anything else for you guys right now. I appreciate you guys taking the time and spending an hour with us this afternoon. I learned a lot and always enjoy talking and learning. So thank you guys.
Thanks again.
Yeah, thanks for making the time.
Jackie. Thanks,
A lot of
Dave.
fun.
I appreciate it.